The last section in this unit is on the quadratic formula. In the first three sections that we worked on, we used graphing, we used factoring, we used the square root method, and that in a combination of completing the square in order to solve for our solutions to an equation. Those methods have advantages to using them in certain situations, but there's a lot of limitations. They take quite a bit of work, and sometimes you do all this work only to find out that there is no solution. The quadratic formula is probably the easiest way, well maybe not easiest, but quickest way to find your solutions. Now the curriculum says you need to know all those other methods, so that's why we do them. If a question doesn't stipulate use square root method or use completing the square method, then use the quadratic formula. So the quadratic formula can be used for solving any equations that are in the form ax squared plus bx plus c is equal to 0. Now, don't forget that sometimes that bx formula or the c, or the bx or the c value could be zeros. So you can still use it even if they're not there. If there is no x squared value, then you can just use plain old, probably just solving the equation or a little bit of factoring and solving the equation, so you don't need to use this formula. So if you have the x squared value for sure in one of the other ones, then you can use a quadratic formula. So the quadratic formula is x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Now, do you need to memorize that? No, it's on the departmental, it will be on the final. It doesn't hurt to memorize it though, so that you know how to use it. So our values in here, the b, a, and c, are just coming straight from the equation that they're giving you. Now there's a part of the equation that we can use to help us see how many solutions a question is going to have and whether we should progress, because if a question doesn't have any solutions, then there's no sense working through all the calculations or doing completing the square or anything else that a question is asking for if you're going to end up with no solutions anyway. So the discriminant is what tells us how many solutions a question has. So we know from 4.1 that a question or an equation can have 0, 1, or 2 possible results, and that depends on our discriminant. And the discriminant is just the area under the square root. It's the b squared minus 4ac. So this little bit right here is called the discriminant. Solutions can be written in simplest radical form or in decimal form. So how would the discriminant determine the nature of the roots or the number of roots? Well, what we do is we solve. We put in our values for b, a, and c into b squared minus 4ac, and then depending on what that equals, that'll tell us how many roots we have. So if it's greater than 0, when we put in our values into b squared minus 4ac and we find out it equals 0, then that means that the value under the radicand, or under the radical, sorry, so under the root sign, is positive. Okay, if it's greater than 0, so we know it has to be positive, so that means that results in 2 possible solutions. Or roots. If when you solve in that b squared minus 4ac is exactly equal to 0, so that means the value under the radical is a 0, then there is one possible solution. So the value under the radical is 0, resulting in one possible root. If when you solve b squared minus 4ac and it's a value less than 0, so that means there would have to be a negative value, then that means there is no solution because you can't do the square root of a negative number. And that was in a couple of the examples that we did in the other sections. So if it's less than 0, then the value under the radical is negative, resulting in no possible solutions. Or roots. Okay, so you're going to get questions where they give you the quadratic equation, and they're going to ask you, determine the nature of the roots, which just means how many roots there are, and then find those roots. So once you found the nature of the roots, just means, okay, are there any roots to this solution? Are there 2, 1, or 0? And then find the solution if there is going to be a root. So 3x squared plus 5x minus 2 is equal to 0. So step number 1 is always identify a, b, and c. So a is a 3, b is a 5, c is a 2. Sorry, c is a negative 2. So then I take my discriminant, which is b squared minus 4ac, and I substitute into that. So b squared means I have 5 squared minus 4 times a is a 3 times c, which is a negative 2. So I have 25 minus 4 times 3 is 12 times a negative 2 is a positive 24. So that equals 49. So looking back up here, if b squared minus 4ac was greater than 0, which 49 is, then I have 2 possible solutions. Okay, so my discriminant is positive. Therefore, there's 2 roots or 2 solutions. So that is the nature of the roots. I've done that part. Then it says use the quadratic formula to solve. So quadratic formula, write it out. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So now it's just a matter of substituting and solving. X is equal to negative 5 plus or minus. I've already done this, b squared minus 4ac, when I found the nature of the roots, so I know that that's going to be a 49. So I can just substitute that in there. If you didn't do the nature of the roots using the discriminant part first, then you would substitute your 5 squared minus 4 times 3 times negative 2. All over 2 times a, which is 3. So x is equal to 5 plus or minus square root of 49 is 7 over 6. So x is equal to 5 plus 7 over 6, or x is equal to 5 minus 7 over 6. 5 plus 7 is 12 divided by 6, so that's a 2. 5 minus 7 is negative 2 divided by 6, so that will reduce to negative 1/3. So my solutions for this is x is equal to negative 1/3 and 2. Now it told me I should have 2 possible solutions, and I did have 2 possible solutions. Okay, the next example says determine the nature of the roots for 1/4 x squared minus 3x plus 9 equals 0. So it's only asking me to find the nature of the roots, not solve the roots. So all I need to do is that discriminant part. So same thing, my a is 1/4, b is equal to negative 3, c is equal to a positive 9. My discriminant is b squared minus 4ac, and you'll notice every time I do this, I write out the discriminant and I write out the quadratic formula. Those are big hints for when you're doing a hand-in assignment. You're going to get marks for those. So b is a negative 3 all squared minus 4 times 1/4 times my c of 9. So negative 3 squared is 9 minus 4 times 1/4 is going to be 4 times, or 4 over 4, which is just 1, times 9 is 9. 9 minus 9 is 0. So from my notes at the top of the page there, if b squared minus 4ac is equal to 0, that means I have one possible solution. Okay, so my discriminant equals 0. So I have one root. Okay, the next example says solve using quadratic formula, leave answers in exact form. So that means if it's a square root of 27, I leave it as square root of 27 and don't change it to 5 decimal whatever. So I have x squared is equal to 2x plus 1. In order to solve this, I have to have everything together on one side of the equation, and my equation has to equal 0. So I have x squared minus 2x minus 1 equals 0. So a is 1, b is negative 2, c is negative 1. So I can check first and see how many roots I should have for this. The question didn't ask you to specifically, so you don't have to. The only time you do is when you, or that you would, and the question didn't ask, is if you have some really big numbers in there and you don't want to go through all of the work and then find out that there's really no solution to this. So in this case, you've got small enough numbers to work with, just go straight to the quadratic formula. So x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So negative b means I have a positive 2, because negative times negative is positive, plus or minus negative 2 squared minus 4 times 1 times negative 1 all over 2 times 1. So 2 plus or minus negative 2 squared is 4. Negative 4 times 1 is 1, times the negative 1 is a positive 4. So right away I can see in there, the 4 plus 4 is an 8. My 8 is greater than 0, so it's positive, so I have 2 solutions. So when I'm finished, I should have 2 solutions for this question. And this is all over 2. So x is equal to 2 plus or minus square root 8 over 2. Now square root of 8, and I'm just going to kind of do this over here as a little aside. Square root of 8 is the same as square root of 4 times 2. So what I want to do in questions like that is pick out and see, is there a perfect square that divides into that value? Because the square root of 4 means that I have a 2. Square root of 4 is 2, so I've taken care of that 4 value. Now I need to do something with that. Well, I just leave it as a square root 2. So square root 8 is the same as saying 2 square root 2. So now what that means is I can simplify. 2 divided by 2 leaves me with a 1. Then I have my plus or minus. 2 divided by 2 again leaves me with a 1 and a square root 2. So my two solutions are going to be 1 plus square root 2 and 1 minus square root 2. And this one told me to leave it in exact form up here, so that is the exact form. Example B, 3x squared minus 5x minus 9. So same thing, I need to have everything over on one side. So that means my A is a 3, my B is a negative 5, and my C is equal to a positive 9. Quadratic formula, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Substitute. Negative times a negative 5 will be a 5 plus or minus negative 5 squared minus 4 times 3 times 9. And that's all over 2 times 3. So I have 25 minus 4 times 3 is 12 times 9 is 108. And that's all over 6. Twenty-five minus 108 is a negative 83 over 6. Now right there I know I don't have to go any further because I have a negative. So that is less than 0. My discriminant is less than 0, so this means there are no solutions. Or roots, depending on what you want to say. Okay, and the last part of this is, of course, the word problem. It says a picture measures 30 centimeters by 21 centimeters. You crop the picture by removing strips of the same width from the top and one side of the picture. This reduces the area to 40% of the original. Determine the width of the removed strips. So if we let the amount removed equal x. So my original picture here was 20 by 30. And what they're saying is you're taking off this amount here and then this amount here. So these both have widths of x. So that's what it looks like. So we know our original area, whoops, that says 20, it should be a 21. Our original area was that 30 by 21, so that's 630 centimeters squared. The new area, it says, was 40% of the original area. So it's going to be that 630 times 40% or 0.40 or 0.4, however you want to write it. So our new area is going to be 252 centimeters squared. So I know from this, for my new area, it was 20 for the width, but I'm taking away x, and the length was 30, but I'm chopping off that little x off of there. So those are my new dimensions. So that means, if I do my dimensions, 30 minus x times 20 minus x is going to give me my new area of 252. So I have 630, and I keep putting 20, it's supposed to be 21, sorry. 630 minus 21x minus 30x plus x squared is equal to 252. So I have 630 minus 51x plus x squared equals 252. So what I want to do is, because I'm going to use quadratic formula and not complete the square, I would take that 630 over, but since I'm doing quadratic formula, I'm going to move my 252 over. So if I rewrite this, it's going to be x squared minus 51x plus 378. So this means a is 1, b is negative 51, c is 378. So my quadratic formula, I'm going to finish this over here. So x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. X is equal to, the negative times negative 51 is positive 51 plus or minus negative 51 squared minus 4, minus 4 times 1 times 378 all over 2 times 1. So this is 51 plus or minus 2,601 minus 4 times 1 times 378 is 1,512 all over 2. So right here you can take a look at that discriminant amount and see if there is going to be a solution. So 26 minus 2600, just ballpark, minus 1500 is going to be about 1100. So its value, the discriminant, is greater than 0, so I should end up with 2 solutions, and then I go from there. So I know I can continue. So x is equal to 51 plus or minus square root of 1089 all over 2. X is equal to 51 plus or minus, this works out to be about 33. Or could be an exact, I can't remember. So now I finished my solution. Let's see, which way do I want to go? I'll go over here. So x is equal to 51 plus 33 over 2, which means that's going to be 84 over 2, which is a 42. And x is going to be 51 minus 33 over 2. So 51 minus 33 is 18, divided by 2 is 9. So I have my 2 solutions, 42 and 9. I have to check and see if they work. So if I put my 42 into my 21 minus x and my 30 minus x, I'm going to have 21 minus 42, which is a negative value, and 30 minus 42, which is another negative value. So it means that I have to reject this, because the area I remove can't be larger than what I originally had. So that means x is equal to 9 is my solution. So the width of the removed strip is 9 centimeters. So you have to watch those questions when you're doing them and not put, even though my discriminant said I had 2 solutions, because it's a word problem, I need to see if both of those solutions will work. And in this case, the amount I was removing was more than the amount I originally had, so I can't use that.